Today our topic is square root functions. So learning target, how can I graph square root functions? Some vocabulary for us to start with. A radical expression is an expression that contains a radical, such as a square root, a cube root, or other root. So just a reminder, a refresher, parts of a radical is we have the radical symbol. The number underneath the radical is called the radicand. The whole piece is a radical. And then this number right here, this one is 3, so that's a cube root, but it's called the index number. So we can have cubed roots, we can have fourth roots, but the most common one that we work with is just square roots. Like the square root of 16 we know is 4. That's what we're going to be focused on today. Radical function is a function that contains a radical expression with the independent variable, which we usually call x, in the radicand. So that means we're doing the square root of x. Square root function is a radical function whose radical is a square root. And that's what our focus is going to be today. Parent function for square root functions. So that's your basic function, which is y equals the square root of x. And the graph looks like this. So it kind of makes a little arc right there. Kind of looks like half of a quadratic function. You know, if you were to finish the other piece, our parabola, that U shape, it looks like it's been flipped on its side almost. But we just get that half piece, all right? So that's the basic function. So that's what it looks like, and that's what we are going to compare to. So we're just going to jump right in, graph the following functions. Y equals 3 times the square root of x, and y equals negative 0.5 times the square root of x. Identify the domain. So the domain are your x values, and the range is your y values. And compare with the parent function, which I have graphed for you on your graph. So the first table we can use for y equals 3 times the square root of x. And the second box we can use for y equals negative 0.5 times the square root of x. Now, if we look, our x is underneath the radical, which means our x values have to be positive. We can't put negative numbers underneath there because it doesn't give us any values out. So we can already say that we're going to plug in 0, 1, 2, and 3. For our y values, we just plug the numbers into the square root and solve for y. For that, our calculator can be very helpful. So if we pull up our calculator, we're doing 3 times the square root of 0. We get 0. 3 times the square root of 1. We get 3. 3 times the square root of 2. We get 4.26. And then 3 times the square root of 3, 5.196. So all I'm doing is taking our x values and putting them in for x. So in our table we can put 0 was 0, 1 was 3, 2 we had 4.24, and 3 we can round up to 5.2. Now to put this on the graph, we just can estimate the best we can. So this is kind of every other. So here's 1 and here's 3. Just plot the points the best you can. We've got 0, 0, 1, 3, 2, 4.24, so that's going to be up here. And then for 3, 5.2, that's going to be like more up here off our graph. So if you look at that graph, it's increasing a lot faster than our parent function. So for the comparison, we could say increases faster. Our domain are our x values. So if we look, it starts at 0. So x can be equal to 0. And then they get bigger, greater than 0. Our range is those y values. So y starts at 0 and gets bigger. So it can be greater than or equal to 0. Next function, same concept, except for now we're plugging our x values in to that function, negative 0.5 times the square root of x. So again, pull out that calculator, type in negative 0.5 times the square root of 0, we get 0. Negative 0.5 times the square root of 1, we get negative 0.5. Negative 0.5 times the square root of 2, negative 0.707, and then negative 0.5 times the square root of 3, we get negative 8.66. So we put those into our table. We put 0 and we had 0. 1 we had negative 0.5. 2 we got negative 0.71. And 3 we had negative 0.87. Again, graph these as best you can, approximating. Here's our 1 value, our negative 1 value, and we're not going to be below that negative 1 value. So we start at 0, 0. Actually graph this in green to differentiate. And then we have 1, negative 0.5, so it'd be about there. 2, negative 0.71, be about there. 3, again, we're just estimating those values. It's okay if it doesn't look great. Just to kind of get an idea of what that function looks like. Now, if we compare 1, it's on the bottom half of our x-axis. It's down here instead of above, so below the x-axis. And the reason for that is because we have this negative piece. Other piece would be it increases slower. Or in this case, it would be decrease. Domain, our x values. If we look, our x values are still greater than or equal to 0. Our range, however, still starts at 0, but they get smaller as we go on, so it's going to be less than or equal to 0. Example 2, graph the following functions. Doing a little bit different stuff here. Y equals the square root of x plus 2. And then for our second one, y equals the square root of x minus 4. So that minus 4 is underneath the square root, whereas here that plus 2 is outside. For our first function, we're still going to have to use 0, 1, 2, 3 for our x values because they're underneath that square root. Plug those into our function using our calculator. We have the square root of 0. Now, the key piece is we're going to have to press this right arrow to get away from the radical to add that 2. Because we don't want that plus 2 underneath the radical. We want it outside of the radical, like it is now. We get 2. Then we do the square root of 1, go over, plus 2. We get 3. Square root of 2, go over, and then add 2. We get 3.41. And then the square root of 3, go over, plus 2. We get 3.73. So 3.73, 3.41, 3, and 2 in our table. Graph those, and we get 0, 2 right here, 1, 3 right there, 2, 3.41 would be about there, 3, 3.73 would be about there. If you look at that, looks about the same as our parent function, except for it's just been shifted up 2 places. So it's shifted up 2. If we can think of a reason why, it'd be because we added that 2. Identify your domain, so those x values. X had to be greater than or equal to 0. And then our range is the y values, which start at 2 and get bigger, so greater than or equal to 2. Next function, we have y equals the square root of x minus 4. So now for our domain, we can't do 0, 1, 2, 3, because if we put 0 in for x, 0 minus 4 is equal to negative 4, and we can't take the square root of negative 4. So the first value we could put in without getting a negative would be 4, and then we'd have to do anything bigger than 4. So 4, 5, 6, 7 can be put in for x. Use your calculator to evaluate this. And we do the square root of 4 minus 4. Now we don't have to go over this time because the minus 4 does need to be underneath the radical. So we're going to keep it there. Square root of 4 minus 4 is 0. And then we have the square root of 5 minus 4, which is 1. The square root of 6 minus 4 gives us 1.41. And then the square root of 7 minus 4 is 1.73. So we put those into our y values. So we got 0, 1, 1.41, 1.73. Graph those on our graph. 4, 0, is right there on our x-axis. 5, 1 is going to be right here where 5 and 1 meet. 6, 1.41 would be about there. And then 7, 1.73 would be about there. Graph that. Looks pretty similar to our parent function here in red, except for it's just been moved over to the right 4. So we can say moved right 4. Domain x values, x is greater than or equal to 4 because we started at 4 and the numbers got larger. Range as those y values, we start at 0, so greater than or equal to 0 because our numbers are getting bigger than 0. One last example, graph y equals 2 times the square root of x plus 4 minus 1. We look for x values that we can put underneath the radical without getting without getting negative numbers. So we can start at -4 and then get bigger than that. So we can plug in -4, -3, -2, and -1. Plug those into our function. Again, your calculator is going to be very helpful for this. Now we have a very large function, so we want to make sure we're getting all the pieces put in correctly. We have 2 at the front, then the square root of our x value, starting with -4, plus 4. Then we have to move outside of the radical to add that -1. Press enter and we get -1. Do the same thing, 2, square root, now we're putting in -3 plus 4. Move over outside the radical, do -1 equals 1. Again, same thing, except for now we're putting in -2 plus 4. Go outside the radical, -1. 1.83 if we round, and then last one, 2 times the square root of -1 plus 4, go outside the radical, -1, equals 2.46. So 2.46, 1.83, 1, and -1. Graph those on your number line. We get -4 and -1. So -4, -1 would be right there. -3, +1, right there. -2, 1.83, be almost close to 2. And then -1, 2.46 would be in between 2 and 3, so about right there. Plot that. That's our graph. So if you can see, comparing it to that parent function, it's been shifted to the left 4 units. It's also been shifted down 1. And then it also grows a little bit faster than our parent function. It's increasing faster. Last step, just identify that domain and range. X values are greater than and equal to -4. And then our range is greater than or equal to -1. That's all the notes I have for you today. I apologize that the video is very long, but thank you for watching and sticking with me, and please subscribe to my YouTube channel.